in chapter 4, lesson 2, we're going to compare and order the rational numbers. But on your notes, you guys know that we took before that we have rational numbers. We're going to write a few things in our book also along the way. It says a rational number is a number that can be expressed as a ratio. Circle that word ratio. When you write a ratio, you write it like a, does anybody know what we write it like?
Fraction.
Like someone said it.
Fraction.
Fraction, yep. So when you are thinking of a ratio, you're going to write it like a fraction. So it's a ratio of two integers written as a fraction in which the denominator is not 0, because you can never have a denominator of 0. The Venn diagram below shows that the number 2 can be called many things. It is a whole number, integer, and rational number. The number a negative 1.4444444, because it continues, is only a rational number. Common fractions, terminating and repeating decimals, percents, and integers are all rational numbers. I want you to put something around this statement that if I say, get out your notes, or you can even use your book on the test, you're going to know that, hey, this is pretty important and this might help me with one of my answers. So if it's that important, let's go back and let's reread it one more time and think about what we just read. It said common fractions. Okay, I know what a common fraction is. It's just a fraction. Terminating and repeating decimals. What does it mean to terminate?
Get rid of.
Anybody tell me? End. Stop.
Oh.
Okay, when I go to divide it, it'll end. Repeating decimals would be like this right here where the 4 kept repeating. We know what a percent is, and integers, those are all rational numbers. They all are encompassed in that. So it says, down here below, we need to write the numbers from the number bank on the diagram. Now, before we go back and start working on this, let's take a step back. Whole numbers, are they negative?
No.
No. But it would be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Can I have a decimal in those?
No.
No. Integers. Integers include all whole numbers, but also their negative numbers. So it's, and it also includes the number 0. Okay, integers also have 0. So then on the outer edge are rational numbers. So if it's a whole number, it's also an integer. If it's an integer, it's also a rational number. But rational numbers aren't always what's on the inside. You have to remember that when you're reading that Venn diagram. So if I have this number bank, 8/10, start at the center. Is that 8/10 a whole number? Yes or no?
No.
Is it an integer? Yes or no?
No.
I need more than 3 people to answer. Is it a rational number?
Yes.
Okay, so then we need to put it in there. 2 and 2/10 repeated. Start on the center. Is it a whole number?
No.
Integer?
No.
So it is a
Rational.
number. Make sure you get the bar above that. A -1. Is it a whole number?
No.
Is it an integer?
Yes.
Good. So if it's an integer, it's also a rational number. The number 1, is it a whole number?
Yes.
So if it's a whole number, it's also an integer, and it's also a
Rational number.
So it's going to be all of them. And the last one is 1 2/3. We only have one spot left. It's rational. But then, we're going to set up to where we have a new term here. It says, not all numbers are rational numbers. The Greek letter pi represents the non-terminating and non-repeating number whose first few digits are 3.14. Does anybody know what finishes that?
159.
Okay, hold on, Katie, go.
I don't know.
3.14159.
26.
Yeah, 3.141
1, 5,
5, 9. And it just keeps going though, right? We're gonna wanna know that for an answer we have to do later. But it said, why is it not repeating? It's because when I put it in my calculator, if I put the pi sign in the calculator, all those numbers are gonna keep going and going and going. It never stops. Even though it'll stop on your calculator, in real life it never stops. So this number is an irrational number. I want you to box that word, irrational number. And then we're gonna write irrational over here off to the side. You might have more room over here.
Yeah.
So go ahead and put wherever you have the most room, you're gonna write irrational numbers, and we're gonna give some examples of some irrational numbers. Okay? An example of an irrational number was what they just gave us, which is pi. Another irrational number might be like 1.23456, and then it just keeps going and going and going. It doesn't stop. Another irrational number would be the square root of 26. Why is the square root of 26 an irrational number? Yes, called it.
It doesn't have like a whole number.
It doesn't have an exact answer, does it? So if I put the square root of 26 in my calculator, it's going to give me a whole number full of a bunch of decimals, because it doesn't stop. So when those decimals don't stop, okay, or repeat, it's irrational. Okay? Alright, let's go on to the next page. So knowing that we have rational numbers, we are going to compare them. So we're either comparing decimals, percents, and fractions. When we compare fractions, we need to make sure that they have a what? Say that again. Common denominator. If I have fractions, if there are two fractions, they have to have the common denominator, which is a common denominator is a common multiple of the denominators of two or more fractions. The least common denominator, or LCD, is the least common multiple, or least common multiple of the denominators. We've worked on this last week in a small group. You can use the least common denominator to compare fractions. You can also use a number line. Use the number line if they tell you to use a number line. Only if they have it there, only if they tell you that you have to. I'm going to tell you from this point on, I don't really want a number line used. I want you to show me the work finding the common denominators. Okay? But if the graph is here, we're going to do it. So it says fill in the circle with less than, greater than, or equal to make negative 1 and 5/6 compared to a negative 1 and 1/6, a true statement. If it's a negative 1 and 5/6 and a negative 1 and 1/6, my number line has to be between a negative 1 and a negative 2. I would split it into 6 parts because it's into 6. So you see, I would start here at 1 and go negative 1 and 1/6, negative 1 and 2/6, negative 1 and 3/6. That's how I would number my number line. And then I find negative 1 and 1/6 is right here. Negative 1 and 5/6 is here. You're dealing with negative numbers. The further away from 0 means does it get bigger or does it get smaller? It gets smaller when I go to the left. Anytime I'm going to the left, because my 0 is all the way over here, I'm getting further away from 0, so it's going on the left-hand side, so it's going to get smaller and smaller and smaller.
Yep.
So a negative 1 and 5/6 is less than a negative 1 and 1/6. For our first got it problem, it says use the number line to compare a negative 5 and 5/9 to a negative 5 and 1/9. Notice my whole numbers is between a negative 5 and a negative 6. How many do I need to split, how many pieces do I need to split the number line into? 9, because my denominator is 9. So I'd say this is like 1, 3, 4, 5, 6, 7, 8, and that would be 9. It's pretty close, not perfect. So then I label it. This would be a negative 5 and 1/9. Negative 5 and 2/9. Negative 5 and 3/9. Negative 5 and 4/9. Go ahead and mark your number line and label it. I'll continue labeling mine. Then I need to put my dots. I have a negative 5 and 5/9. Put my dot right there on my number line, and a negative 5 and 1/9 is here. This is further away from 0. So a negative 5 and 5/9 is less than a negative 5 and 1/9. Our next example does not have a number line. So I'm comparing 7/12 and 8/18. I want you to rewrite those two fractions over here. I know, they give you the answer here, but I'm gonna show you something. So if I have 7/12 and 8/18, you have to find a common denominator, correct? Okay, their common denominator they knew was 36. Well, to be honest, I don't know my 18s all that well. Do you know your 18s that well?
Kinda.
Do you know your 12s aren't, we're pretty good at our 12s now because we should have that, but the 18 isn't one that I have in my number bank all the time, okay? So if I didn't know that, I'd have to count by 12s first. 12, 24, 36, and then I have to count by 18. 18, 36, and then I would have known it's 36, okay? But hold up a second. I'm gonna come back to what I told you guys to write down. Can I reduce 7/12?
No.
I can't. But can I reduce 8/18?
Yeah.
By what? Not 8,
Oh,
just 2.
Yeah.
That's it. But I can reduce it, and it becomes 4/9. Do I know my 9s?
Yeah.
I should. Do I know my 12s? I should. So I'm gonna go count by 12. 12, 24, 36. What is the next?
48.
Okay, but I probably can stop because if I know my 9s, I go 9, 18, 27, 36. What's my common denominator going to be? So watch how I do this. If I get my 7/12 and I want it to have a common denominator of 36, you have to show that I'm multiplying by 3/3 and I get 21/36. Okay? Then, with the 21/36, isn't that the same as this one over here? So that's the same there. But, how do I get from 9 to 36? Times 4. And do I know 4 times 4 really easily in my head? That's 16. Did I get the same fraction?
Yes.
Yeah, but it was a little bit easier because I reduced first. Did I still find common denominators?
Yes.
Yeah, and it's still the same common denominator. So if I'm comparing 2136 and 1636, 2136 is greater, because 21 is greater than 16. So let's look at some problems and we'll do it together. 5, 6, and 7 ninths. Can I compare them the way they are?
Nope.
No, I can't. I have to find a common denominator. So if I count, and I want you guys to write it over here, counting by sixes, 6, 12, 18. Can I stop? Because if I count by nines, I go 9. What's my common denominator going to be? Now, to show your work underneath of it, you're going to rewrite the original fraction, 5/16. You're going to show that
Six.
it's
It's 6.
Oh, 5/6. I said 16, but wrote 6. Thanks, guys. And my denominator is going to be 18. You have to show me how I got from 6 to 18.
Times 3.
Times 3. So then you have to show me that you're taking 5 times 3. So now I have 15 18ths. I'm going to do the same thing. Write my original fraction, 7 ninths, equals something 18ths. How do I get from 9 to 18? And I have to do 7 times 2, which is
14.
Now I can compare the numerators. 15 is greater than 14. Make sure you are showing your work. 5 and 50. What is going to be my common denominator?
10. Oh,
Can't be 10. 'cause
15.
It can't ever be lower than the
Yeah.
biggest number, so it has to be 50. So I'm going to bring down my 1/5 equals. Now, how did I get from 5 to 50? Maybe that's why some of you guys are saying 10. So
Yeah.
times by 10. So I have 10/50ths compared to, and I don't have to change that 7/50ths. But 10 is greater than 7. 9/16 and 7/10. If I count by 16s, I can't think of anything right now that's gonna end in 0. Can any of you?
160.
But I can come up with 160, because I'm just going to take 16 times 10. So bring down your 9/16
And half of it, which would be 80.
equals 160, so I have to show times it by 10, times it by 10. So now I have a negative 90 160ths. Then I bring down my original number. How do I get from 10 to 160? That's times 16. I don't have 7 times 16 memorized. I don't. So over here, I'm going just to take 16 times 7.
112.
7 times 6 is 42. 7 times 1 is 7. 7 plus 4 makes
11.
So now I have 112. It is okay to write it over here to make sure you have it correct. But it's a negative. Now, if I know I'm comparing negatives, is a negative 90 further, or is a negative 112 further? So a negative 90 would be greater than.
That's 3 times in a row.
3 times in a row, yep. All right, let's go to the top of the next page. So far, you're doing great. You're confused. You're doing okay. Let me see. Well, how are you guys doing? I need to see everybody's. You got 3 choices. All right. All right. Let's look at example 3. In Mr. Huang's class, 20% of students own roller shoes. In Mrs. Trevino's class, 5 out of 29 own roller shoes. In which class does a greater fraction of students own roller shoes? It says greater fraction, but do I really have to put it in a fraction form?
No.
You don't. You can make it all decimals to make it easier. 20% I write it as 0.20, correct?
Yeah.
Should be writing this down on one side or the other. 5 out of 29. Can I make my 29 equal 100 easily? No. So that's when I'm like, okay, if I know I can't do that, I'm going to do my division. 5 divided by 29. 29 doesn't go into 5. Add the decimal, add your 0. 29 goes into 50. So I've got 21 left. Add another 0. Bring the 0 down. 29 goes into 210.
3.
7.
Oh.
So 20, well, if I think this is about like a 30, 30 goes into 210 about 7 times, because 3 times 7 is 21. I'm gonna take 29 times 7 over here. 9 times 7 is 56, right? 7 times 2 is 14. 14 plus 5 is, okay. Now, can I do I have to finish doing this?
No.
I really-
Sometimes some is 63.
56.
I thought, okay, thank you.
Yeah. We're still learning, so it's off the game.
So this would be 14 plus 6 is 21, right?
Yeah. That's too much.
That would be 20.
That's not
That'd be
bad.
20. Okay, but I am still gonna stop here, okay? Because if I look, and I'm just comparing my decimals, I have a 2 in the tens place for 20%, and I have a 1 in the tens place for the fraction. Which one isn't a 2 greater than a 1? So I don't even though some of the division can take forever, be careful, you don't have to go all the way. Does that make sense?
Yeah.
Just get it to where you have the numbers that you can compare. So let's look at E. In a second period class, 37 and 5/10% of the students like to bowl. In a fifth period class, 12 out of 29 like to bowl. In which class does the greater fraction of the students like to bowl? So if I'm taking 37 and 5/10, I'm changing that to a decimal, which means I just move the
That's just to the left.
to twice, right?
Yeah.
So I have 0.375. It's 12 out of 29, so I write that as a fraction,
12 over 29.
12 over 29.
And then you do the.
29 doesn't go into 100 easily, so I need to do my
Your
division. So 29 divided by 12.
No, 12 divided by 29.
That's exactly why I did it. One person stopped me. All of you like to do this. Because all of you like to put the bigger number on the inside. Wrong. Numerator divided by denominator. You guys have got to make sure you have the order correct. Because that's why several of you miss it. It is, and especially when I start throwing out calculators and you guys just get to use your calculator. I have to see that you set it up and you show me the division. So let's say I'm gonna say, hey, today you can use your calculator, even though I'm not today. If I did, just teasing you, seeing if you guys are paying attention. So if I did though, I need to see the fraction, I need to see the division problem, and then I would see the answer. So we know it cannot go into 12, but it can go into 120.
4 times.
30, yeah, just about 4.
I did
4
what you said.
times 29. 9 times 4 is 36. 8, 9, 10, 11. 4 left. Okay, can I stop even though?
Yes.
Yeah.
Because I compare my
4 to the 3.
tenths places.
Wow.
And 4 is greater than
3.
3. So 12 out of 29 is greater than the 37. Now, if it would ask you to find that and finish it as a percent, then you might have to do that. But we're just comparing the two. So stop when you get to the point that you're comparing. The last thing that we're gonna do is order rational numbers. It's the exact same thing as comparing them. The only thing is I'm getting more than one number. And I just have to put them from least to greatest. You still have to either make them all fractions or all decimals. You still have to do that. So if I have 3.44 pi, this is where that came in handy. This is where we need to know. How do I write pi? If pi is 3.14159, whatever.
2.26.
Okay, I don't need to go any further. Remember, you only go up to the numbers. Then I have 3.14 and 3.4 repeated. Don't these look about like they'd be the same?
Yeah.
Okay, but here's the deal. You better go out one more. Because if this is repeated, if that's repeated and I only repeat it once, it looks like it's the exact same number. But it's not. Because you write it one more time. How would I write 3 and 44 hundredths? What do I put in the? A zero. So now I'm really comparing 440 to 444. That's why we wanted to know pi. Because this would be 1, 4, and what do I put after that? A 0. So now we need to go from least, right, to greatest. So the 3.140 is going to go first. So I'm going to write 3.140. On the bottom or the top of it, write your original number. Then I go 3.1415, and underneath that, that was really labeled pi. Then I go 3.440, under that